Very simple device looked at on Friday. So it's like a square, a rectangular bottom, right? And we had that tube that kind of extends up like this. And you have the big dome on top. I'm actually going to go. Great. Felt great. So on the bottom we have a little cylinder. It's made of felt. That's way too big. It's made of felt. It's kind of purple felt. That's why I drew it as purple. And then what was the top cylinder made of? I remember? No? The top cylinder was made of some sort of plastic. I don't really know what kind of plastic, but some sort of plasticky type device. The belt is made of rubber. Right? And so that's going to stretch between. And bottom, there's also a little metal screen that's very, very close to the belt. This one's attached to the lid. And this bottom little metal screen is attached. It doesn't touch the belt, otherwise it would scrape it and not be good. It's like a little metal grating. This one down here is attached via the plug. What's that symbol there for? The ground. Good. So this on the bottom is a metal screen. It's attached to the ground. And so again, this little like mesh screen. You can see the one on top there. There's this little mesh screen, and it's like that because that gives it more surface area, which means that you can help move charge more effectively. All right. So if I turn the Van de Graaff on, that's going to cause the felt to start spinning, and if felt spins on rubber, what do you think happens? So which one becomes positive? The felt or the rubber? What? Felt, good. Rubber is low on that triboelectric scale. Rubber will almost always become negative, barring some other weird, maybe with the plastic, but especially with a felt type of any kind of usually clothing material behind that list. So the felt is going to give electrons up to the rubber belt, so making the felt excess positive charge and making the belt get some negative charges. Okay? Questions about that? So the belt is rubber. Is that a conductor or an insulator? Good. So the rubber is an insulator, and so can charges flow freely on an insulator? No. And so the electrons are just going to basically ride that belt up to the dome, much like as if they were on an escalator. Now the problem is the felt eventually is going to stop giving up electrons, right? So, but the Van de Graaff never stops getting charged. So how do we? Those two things are both true. Things can only give off so many charges before they're going to be out of excess charges. And we know the Van de Graaff never stops getting more charges, though. So how do we resolve that conflict? Where is these more charges coming from? The Earth, how?
Because it's surrounded by that screen, and the Earth is an electron state.
But what makes the electrons don't just move randomly? Why? How do we get electrons up? Kevin? Good. Or I don't think you need to go that far. We can say the felt is positive. The felt's going to attract electrons, and the felt's going to pull electrons out from the Earth like this. And so you're going to end up with electrons being pulled up from the ground onto the belt. And so I've never really been sure if the electrons go to the felt first and then down to the belt, or if the belt just catches them on the way. I don't know that it really matters which one is true, but that's how we're going to get electrons up from the ground. They're going to travel up the belt then, right? So now we have this, basically infinite supply of electrons, and that's why the Van de Graaff is so awesome, because you're basically never going to run out of electrons, unless the Earth were to collapse and die, which probably won't happen. Okay, so now this thing's pulled up charges. The top cylinder is plastic, the belt is rubber, and so we're going to have another interaction there. Now this time, I'll just tell you because maybe you wouldn't guess this, the plastic cylinder is going to become negatively charged. It's actually lower than rubber on that list, so this top cylinder becomes negatively charged by taking some electrons off the belt. Once it's full of electrons, this is why it doesn't, it has to charge up a little bit. Once that cylinder is full, as much charge as it can take, it's going to be negatively charged, but there's still more negatives coming up from the bottom. And so what do you think is going to happen to the electrons that are on the belt? They're going to jump off. Why would they jump off? Good. So the electrons up here are now going to be shoved off onto this little wire mesh piece of mesh wire there. And that wire mesh is attached via a wire to the dome. So if you can look on here, I guess the mesh is actually just screwed right into the dome. And so electrons jump onto that little mesh metal there. That's how they get transferred onto the dome. That mesh is attached to the dome, and then that's how the dome is charged. So it's pretty simple, just conductors all tied together. And the belt comes back down. I've read different things about this. I've never really tested it. I don't know at this point if the belt is neutral or positive coming back around the other side. I don't know if it loses so many electrons that it becomes positive, or if it's neutral. It doesn't particularly matter. But if we say it's positive because it lost electrons, that actually would even help it back down on here. If this belt comes back positive, that's going to help it draw more electrons off the Earth. And so that would be a good thing. If it was neutral, it would still work, though. And that's the basic gist of how the Van de Graaff works. Questions about that? That makes sense? There's another video I'll probably put up on the site. You don't need to watch, but it'll be there for fun. That other people explain it with the same Van de Graaff. The difference being, though, that their Van de Graaff, they have the two rollers switched. So what would change? What?
The electrons would be going down.
So what would the dome be in that video? Positive, right. So just to reiterate, every explanation that we give in class can be flipped for the other set of charges, right? So now if this bottom roller were plastic and the top one were felt, that would mean that as this bottom roller got charged negatively, it would just shove electrons off the belt down to the ground, leaving the belt positive to come up. Then it would draw electrons off the dome, leaving the top positively charged. And so it's the same idea, but it's just reversed. And all the demonstrations work exactly the same. To me, this way is more what I like to say intuitive, like this makes more sense, but it'd be exactly the same way if it was flipped around. But then eventually the dome would become so positive that it couldn't give any more charges away. You would discharge it with the discharge one like we did on Friday. That would get extra electrons back onto the dome, and the process can keep repeating over and over again. So there's a point, like the Van de Graaff won't become like, there's a point where this thing's going to get so many negative charges. Eventually it will get full. Like it can't just charge forever, it'll get full, and that's when it starts to want to shock things. But it can only hold so much charge before it's done. Okay, questions about the Van de Graaff? We're going to go back and look at our demos again, try and explain. Yeah?
So if the dome is positive, when I was looking at the sink, would I feel the charge first when you connect it?
It's going to move at the speed of light, so I doubt you're going to even notice the difference. So yeah, I mean, it's almost instantaneous. I mean, nothing is instantaneous in reality, so it wouldn't be exactly instantaneous, but you probably would not notice the difference in the timing, to be honest. Other questions? All right, let's move to the back of the room again.